Hello, everyone. My name is Ribel Yacob. I am a sophomore electrical engineering major attending the University of Maryland, College Park. My research advisor and mentor is Mr. Wendemu Zegia. I conducted my research through the Smart Cities Research Experience for undergrads at Morgan State University, the focus of my research being Internet of Things security. To introduce my research, this presentation is called Private Certificate Authority for Internet of Things. So for some background on my research, the Internet of Things, or IoT for short, is a technology that is becoming revolutionary in the way we live today. IoT is seen in all aspects of life, ranging from transport to health and from entertainment to even our interactions with the government. With the increasing number of IoT devices in our daily lives, there is also a critical need to secure all of these devices as they are an important component of our national infrastructure. With the looming threat of cyber attacks, it is essential for IoT devices to be secured using different methods of encryption, one method being the use of digital certificates generated from certificate authorities as part of a public key infrastructure. In simple terms, the role of a certificate authority is to validate the identities of users through the issuance of digital certificates, the ultimate goal being to secure the communication between two entities. So some of the goals I set for my research include first creating my own private certificate authority, which will allow me to deploy digital certificates for an IoT device. Then I would test said certificates by using them to secure a locally hosted website. Finally, I would use the digital certificates to secure my IoT device, which will be a Raspberry Pi, and I will manage the device using Amazon Web Services IoT. Some of the software and devices I'll be using include the Ubuntu Linux operating system, which will be used to run the commands needed for when I create a private certificate authority. I will also be using a virtual machine to run the Ubuntu Linux operating system in a virtual environment for testing purposes. Additionally, I will be using a Raspberry Pi, which will act as an IoT device communicating securely. And finally, I will be using Amazon Web Services to communicate with my device. So what is a public key infrastructure? So basically, it's the framework for encryption of communication between communicating parties. Whether it is sending an email to someone or just signing into an account, a public key infrastructure works to secure the communication between you and the server in question. There are multiple components to a public key infrastructure, which I'll briefly explain. First, there is the registration authority, which verifies a user certificate request and tells the certificate authority to issue a certificate. Then there is the certificate authority, which binds a certificate with cryptographic key pairs as a way of providing security. The certificate is then placed in the directory, which is basically a storage for all public certificates. So basically, if you refer to the illustration, there are two users, Alice and Bob. If Alice wants to send an email to Bob, she needs to make sure that the person she's sending the message to is indeed Bob and not a stranger intending to intercept the message. Therefore, she must request for Bob's certificate, which will verify his identity and secure the communication between them. So why use a private certificate authority over a public one? So a typical public key infrastructure often relies on a third-party public certificate authority. However, a problem arises when an organization seeks to provide private services to a select group of people because a typical public certificate authority will issue a certificate for anybody. Therefore, it is essential to ensure that our private services are secured with certificates issued by our own private certificate authority. So throughout the process of setting up the private certificate authority, I made use of StepCA, which is an open source certificate authority toolkit used for creating public key infrastructures and certificate authorities. All of this was done on the Ubuntu Linux operating system, as this allowed for more configuration accessibility. Next, we must generate a certificate chain. The purpose of a certificate chain is to validate a user certificate by connecting said certificate back to a root certificate of a verified certificate authority. As you can see in the diagram, there is an IoT device with a certificate. The IoT device's certificate has its name, its public key, and a signature from the intermediate certificate authority. To the right is the intermediate certificate authority certificate, which is signed by the root certificate authority. And finally, all the way on the right is the root certificate authority certificate signed by itself, since this certificate was generated automatically when creating the private certificate authority. So why do we need the intermediate certificate authority if we can simply connect the IoT device's certificate back to the root? So the intermediate certificate authority is put into place as an extra layer of security. When deploying possibly many certificates for different IoT devices, you can relay that responsibility to multiple intermediates rather than having the root certificate authority deploy all of the certificates. And now, if one of the intermediates were compromised for any reason, only a few IoT devices would be compromised rather than all of them if the root certificate authority deployed all of the certificates itself. So the next step is securing a locally hosted website on the Ubuntu virtual machine. First, I deployed Apache, which is a very popular web server software that enables you to host websites that can be accessed from the internet. Next, I added my newly generated certificates to the Apache configuration file and created a simple website HTML. When accessing the website, I receive a welcome prompt, which I previously embedded into the website. There is also a lock besides the URL, which means the website is being secured with HTTPS using transport layer security. Transport layer security, or TLS for short, is a security protocol on the transport layer that creates a tunnel for secure communication between an application server and a user. A typical unsecure website displays a warning and most likely uses HTTP protocol rather than HTTPS secure protocol, which encrypts all of your data so no one is able to read it. The reasoning behind securing a website was to have the website act as an application running on an IoT device for testing before eventually securing the Raspberry Pi. So the next step was to configure the Raspberry Pi using the same setup process previously done on the Ubuntu virtual machine. So after deploying certificates and securing a locally hosted web server, I can move on to getting the Raspberry Pi to connect with Amazon Web Services IoT. So the first thing I did was create an Amazon Web Services IoT account and uploaded my certificates under the name of the IoT device. Then I did something called attaching a policy to the IoT device. The role of the policy is to define the permissions of the IoT device when it communicates with Amazon Web Services. For the purposes of this project, I allowed all actions and set the Raspberry Pi to act as an IoT device communicating with Amazon Web Services. So what is Amazon Web Services IoT? Basically, it is a service provided by Amazon Web Services that makes it easy to securely manage remote IoT devices at a large scale. For the purposes of this project, I am simply managing one device, and that is the Raspberry Pi. In the previous steps, I set up the IoT device for communication from the Amazon Web Services IoT dashboard. The next step is to communicate with Amazon Web Services from the Raspberry Pi. To do this, I must send data in the form of a message to Amazon Web Services from the Raspberry Pi using Python and MQTT messaging protocol. For the results, I was able to successfully create my own private certificate authority to deploy certificates for the Raspberry Pi. I was also able to secure a locally hosted website on the Raspberry Pi using the certificates generated by my own private certificate authority. And finally, I was able to connect the Raspberry Pi to Amazon Web Services IoT by sending a message to the Amazon Web Services IoT device manager using MQTT messaging protocol. In terms of future work, I hope to continue learning about cryptography and its applications. I also hope to further my understanding of Amazon Web Services IoT, furthermore being able to connect and manage multiple devices in the future. Before I conclude this presentation, I would like to acknowledge a few people. Firstly, I would like to thank Dr. Kofi Nyarko, who was the program director at Morgan State. I also appreciate the work he did keeping the program very collaborative and interesting, even in these tough circumstances. And I would also like to thank my mentor, Mr. Wendy Muzege. He was a great guide during my first research opportunity, and he was always there to guide me in learning something completely new And as a result, I have gained an appreciation for a new topic of Internet of Things and cybersecurity, which I hope to further explore in the future. And here are my references. Thank you all for listening.